Hey everybody, let's take a look at a calorimetry problem. This is going to be question 5.53 in Brown, LeMay, and Burston. And this has to do with how much energy is required to heat something up in order to, it's dealing with heat transfer. Okay, so I've copied this right over here. And it gives the specific heat, and you will always be given the specific heat unless, of course, you have to solve for it. But it's a constant. It's something you can look up, so that's not anything that we shouldn't have to struggle about. Okay, it says how many joules of heat are needed to raise the temperature of 80 grams of octane from 10 to 25 degrees Celsius. So if we're talking about changing the temperature, or how much heat, joules of heat, that's kind of the context clue, are needed to do something. Okay, typically that's going to mean that we're calculating a Q, or we need to find a Q. So the formula that allows us to calculate the amount of heat needed to raise a temperature is Q equals mc delta T. And this is a process that we call calorimetry. Okay, calorimetry. And it's the same calorimetry. It's the same sort of thing that we do when we eat. We're burning calories. Well, this is the same thing, except now instead of getting it from food, we're getting it from other chemicals. And octane, coincidentally, is the chemical that is in gasoline, the major component of gasoline that burns, and so it gives off a lot of heat. And so we want to know exactly how much. Okay, so in order to solve this problem, it's a direct plug and chug. Okay, so what is the mass? 80.0 grams. What is C? C is this value here. Okay, 2.22 joules per gram Kelvin. And then delta T. Okay, let's keep in mind that delta T is TF minus TI, and I hope that we know that if we're trying to find the change in temperature, we don't have to convert to Kelvin, only for changes in temperature. Okay, so we're going to go temperature final. The final temperature is 25 minus the initial temperature is 10, so the delta T is equal to 15. Okay, so now we have the mass, we have the specific heat, and we have the change in temperature. 80 times the specific heat is 2.22 times the change in temperature is 15, and so now we can do the math. 80 times 2.22 times 15, and we get Q equals 2664 joules. Okay, now it says which will require more heat, increasing the temperature of 1 mole of C8H18 by a certain amount, or 1 mole of H2O by a certain amount. Now, well, I guess we could do the math here, but okay, so let's do the math. Okay, I was gonna do like a little conceptual question, but we'll do that afterwards. Okay, so for part B, again, we're gonna do Q equals mc delta T, but in this case, we're gonna use 1 mole and 1 mole. So 1 mole of C8H18 and 1 mole of H2O. Well, 1 mole of C8H18, now in order to get the grams, because we want the mass, we have to do the molar mass. So we do C is equal to, so there's 8 carbon atoms times 12, which is the mass on the periodic table, which equals 96. And then we have H, there's 18 H's times 1, which is the mass of the periodic table, which is 18. So 96 plus 18 is equal to 114. Okay, so Q, the amount of heat, mass, so 114 times 2.22 times delta T, let's see, so 114 times 2.22, the amount of heat is going to be equal to 253.08 times whatever our delta T is. Now, that's for what we call octane. Okay. Now we're going to compare that to the amount of heat needed, okay, for a mole of water. Q equals mc delta T. Now for water, H2O, the molar mass is, let's see, H, there's 2 H's times 1, the mass of 1 on the periodic table, so that's 2. And then for oxygen, there's 1 oxygen times the mass on the periodic table, which is 16. So when we add that up, that's 18. So now, 18 times the specific heat of water, 4.18, times delta T. So now, 18 times 4.18, so this is 75.24 times delta T. Okay, so this, the octane, is going to require more heat because this value is bigger than this. Okay, so that's how we answered that question 5.53. Okay, so I'm going to leave the philosophical stuff for part B out of it. Okay, so that's 5.53, shows how to calculate or do a calorimetry calculation. Okay, have a great night.